What's up guys, I am here to explain lead code question number 395, longest substring with all at least k repeating characters. So what we have to find is, in a given string we have to find one substring which has at least k frequency of each unique character of that string. For example, in the example 1, the frequency of A is 3 and the frequency of B is 2. Okay, so the best substring that we can get is AAA, because we can't pick these B characters because the frequency of B is 2, so we can't pick them. Same goes for example number 2. If we have k equals to 2, what we can do is we can pick A because the frequency is 2, so it's at least k, and also we can pick B because the frequency is at least 2, because the frequency of B is 3, so we can pick B also. But we can't pick C because the frequency of C is 1, so we can't pick C. So the length that we can pick is A B A B B, so the answer will be 5 because the length is 5. This is what we are gonna do in this question. So now how to approach this question. Okay, so let's make some observations first. So first observation is that if there is any character which has less frequency, it cannot be picked whatsoever. The substring should not have that character. Okay, which means that this C should not be in our in the valid substring. Okay, which we this is one observation. So let's try to make one sample test. Okay, like we have okay, we have this string, and we have this string, and we have to find, and the case 3. Okay, and the case 3. So what can be done? We if we count the frequency of A, 1 2 3, in this string, A can be picked, B can be picked, C is occurring 1 2 3 4 times, so C can also be picked, but D cannot be picked because there are only 2 D's in this string, so we can't pick D. Okay, which means that our a substring can be only either this or this. It can either come from here or from here. Now in this substring we will find whether the frequency of each character is up to our requirements or not. Okay, A is occurring at least A is occurring 4 times, so it's cool. B is occurring 3 times, so it's also cool. But C is occurring only 2 times, so we can't pick C, which means that out of this string we can only choose from AB, AAB and AB. Now we will check out of these strings which can be the valid substring. Okay, same goes to here. We will count the frequency of each character and then just make our answer. So this approach is called divide and conquer. Now we have to implement this. Okay, this can be done very easily. Let's first make a function that will be called recursively and will gather the answers for each of the substring that we make out of that current string, and then just pick the maximum value out of it and then just return it. Okay, and our integer k also. So first observation is that if a string is empty, so we'll just simply return 0, because string of because k can be at least 1. So if the length of the string is empty, which means that there is no length of the string that we can return. Okay, same goes if the if the length of the string is greater than k, which means that the length of the string itself is more than k. So how can we get a character of which frequency is more than k, right? That's this logic. So we'll again return 0. Okay, now what we are gonna do, okay, suppose we have this string a b a b c. Okay, we will iterate from left to right and then just construct our temp our string from the absolute left, and then just one by one we will add elements to it. And unless we reach one element which has the lesser frequency, we will just start searching out of that string that we have created. Okay, so this is how we can build our solution. Okay, let's begin. We are iterating through all the characters in the given string. Okay, also this is an integer which will carry our answer. Okay, cool. Oh, before that we have to count the frequency for each and every character. Okay, so for that we can create a hash map. Okay, we have created our hash map. Now again we'll iterate through the string. If the frequency of that character c is less than the required character k, which means that we can't pick that string, we can't pick that character, and the substring can't have that character in it, we will just search out of the string that we have built till now. Okay, and then we will reset our string that we have built. Cool. Also we should do this only when we have some amount of characters in our temp string. Okay, and then we'll just continue. But if the frequency is okay and we can use that character in our string, we will simply add that character to our temp. Okay, cool. Now at last, if the length of temp comes out to be as equal to as the initial string s, which means that all the characters were acceptable, it implies that the initial string is all good to be used as a substring, and we can just simply return the length of that string. Okay, so if temp equals to s, we can just simply return. Cool. Or if it's not the case, we also have to find the value for the longest substring out of that temp and just update our answer with the value. So our recursive function is done, as we can see. Okay, now we'll simply return solve as k. We will just dry run this code in a while, so don't worry. Okay, so we are getting 0 for all the cases. Let's see where we are getting it wrong. Okay, we have created our cache frequency and answer C is frequency of C is less than K. Oh my god, yep. As the length, if s dot if the length of string is less than K, that means we have to return 0. Okay, let's dry run this. Okay, over some good example. Let's take the string which is K equals to 3. Okay, okay, good. Let's suppose our string is this and the K is this. Okay, now let's dry run on this string. Okay, initially the temp is this. Okay, initially our temp is this. Okay, and we have also calculated all the frequencies for this, right? So like for A it's 1 2 3 4 5. For B it's 3 5. For C it's 1 2 3 4 6. For D it's 2. Okay, so in this trick, let's just check. Okay, we first go to A. Okay, the frequency is cool. B for B it's cool. C it's cool. A is cool. B is cool. C A B C is okay. But now we have arrived at D, so we can't pick D. Okay, now we will try searching on this string. Okay, we will try searching on this string. Cool. Okay, now we are on D, and again we start A is cool, B C A B C C. We are all cool here, so we can start searching on this string again. Okay, A B C. Okay, again here. Okay, again we start searching on this. K is 3 again. A for A it's good. B for A frequency 1 2 3. Okay, A is cool. B is also 3. C is also 3. So the entire string is good, so we can just simply return the length 1 2 3 4 5 6 and 9. So the 9 can be returned to here. Now here 1 for A is only 2, right? So we can't use A, we will be using this. Okay, so it has B C A B C, so B also cannot be used, so we are remaining with C A B C C. Okay, now C can be used but A cannot be used, so we are here with C, but C is less than K, so we will return 0. A can also not be used, B can also not be used. Okay, now for this B cannot not be used, so we use C. This will also return 0 because it's less than K, so this will return 0. So this string will be returning overall 0. Okay, now here we will just compare the maximum of all the values, so it's going to be, I think, 9. Let's just test this. Okay, A B C A B C A B C D D A B C A B C C, and the K is 3. Let's try to run. So the answer is coming to 9 as I said. Now let's try to submit this code. Yeah, so as you can see, our code got accepted. Okay, now let's discuss time complexity of this. Now time complexity can be for each recursion we are traversing through the entire string. Okay, and max to max we have a call stack of big of n, so our time complexity can be big of n square. Okay, time complexity, also the space complexity is for each recursion we are using linear space and the call stack. So space complexity is okay, this is how it goes. So I hope you like the approach. Thank you and see you with the next one. Bye.